Um, I'm Alan Jones. I'm the chair of the Richmond chapter of the Computer Society. And the talk today, Dejan, I'm going to have to ask you to pronounce your last name. I got the lesson on the pronunciation of the first name, but the last name I didn't write fast enough. So
Dejan Milojicic.
Okay. Is going to talk with us today about technology predictions from the Computer Society and also the Future of Work study. And today's presentation is being recorded so that people who aren't able to attend live can view it later. And it's hosted by the Computer Society Richmond chapter, the Magnetics and Engineering and Medicine and Biology Richmond Joint Chapter, the Computer Society Northern Virginia Washington Joint Chapter, the VCU IEEE Student Branch, and the Virginia State University IEEE Student Branch. So I'll turn it over to you.
Thank you very much, Alan, and thanks for being patient with me. Alan has been inviting me for almost a year, and we decided to wait until the predictions were out. So I will give you two talks, as Alan pointed out. The first is on 2022 technology predictions. This is the work of about 18 people, and more help make this document happen. So I'll tell you a little bit about the team landscape, individual predictions. I'll compare them and then summarize. And I got some extra materials about related predictions that you may find interesting. So in the past, these predictions were really hypothetical exercises. Few people believe in them or believe to a certain extent. There was a lot of market analysts who make predictions by talking to a number of companies. But as of lately, especially with COVID, when almost anything you can do is predict, they really became part of the critical planning. The level of confidence was pretty low, but you still have to plan. So you can see that there was a huge economic impact. And I mean, really, the lives of people were affected even more so than these numbers in terms of money, and not just human lives, but those who remained, supply chains, work, unpredictability of operations, markets, everything. So people introduce all kinds of countermeasures. They repurpose assets, eliminating middlemen, shift to as a service model. So people have to adjust. I mean, even the talk that is being given now, in the past, as a distinguished speaker, I would normally visit your section, chapter, and give a talk. But as you know, most of the talks are now given remotely, even though people are now moving to a hybrid model. So in general, pandemic has created this stress on our daily lives, our values. There's social distancing, future of work is changing dramatically. People are working from home. There's acceleration of digital transformation, which was forced upon work, education, and private life in literally all facets. And technologies are really playing an increasingly crucial role. And predictions, they now go way beyond hypothetical exercise. And we are really encouraging technologies to address these pandemic concerns, but also many other aspects. So here are the pictures of the people who participated in these predictions. So I'll tell you a little bit about the process, but it is really the value and knowledge of these people, their expertise, that has created this, rather than some elaborate science. So the process is relatively simple. We expanded our team from 12 to 16 members. We added quite a few more women, people from Africa, Asia, Europe, South America. These 16 authors made one or more predictions. We overall started with about 36. We combined some of them. Then we down selected to around 11. by each author giving 12 votes. I'm telling you a little bit about the process just so that you know how how these predictions came about. And then I recommended that we add a few more. So we decided this year to go with 16th technology. We agreed on 15th before, and the team agreed. In the second round, we graded them. So what was the top in the beginning didn't end up, because you change your criteria. We graded for likelihood of happening and for desirability of the technology. So everyone gave grades from A to F for these two comparison criteria. We also graded them for technology readiness level, which is pretty accurately defined by, I think, Department of Energy. And we tried to assess total addressable market of these technologies, but we decided that neither was sophisticated enough, and they were all coming from disparate sources that we've got. So we decided not to use them this year. Every year we try to improve a little bit to make it more rigorous as it can get, because it can't really. But we came up with this. You will see that for comparing them at the end of the year, we are even more critical. So we ended up with only grading for likelihood of succeeding and this desirability, and you will see at the end. We define desirability as how desirable this is technology to humanity, individuals, groups, countries, etc. And when we say likelihood of succeeding, we think not necessarily that they will make, which is the ultimate criteria, financial success, but advancement of adoption, because these technologies are at different maturity level, so they can only advance as much. So it's really the delta in their progress, whether they're accelerating, decelerating, and things like that. We calculated our confidence and standard deviation in voting, you'll see at the end. And for each of these 16 technologies, we created one slide discussing problems, demand, opportunities, impact, and then sustainable solution and business opportunity. That gives a little bit more perspective. And we primarily focus on computer science aspects. Most of us are computer scientists or in related fields, so we didn't really look beyond that. So here are 16 technologies. I will just give you a minute to read them. I'm not going to read it for you. What I will say is that the numbers or grades at the end represent, respectively, likelihood of success and desirability as we perceived it. That is, everyone graded, and then we calculated the average among these 18 team members. So I will move on. I put them in kind of semi-architectural diagram just to show that, linear list is usually hard to remember, comprehend, but we pretty much covered the whole space. You can argue whether this is the right diagram, but there are core technologies. It's more of a grouping. So there are some core technologies like convergence of HPCI and HPDA. HPDA stands for high performance data analytics, non-fungible tokens, then security in different incarnations, either cybersecurity or disinformation detection and correction or confidential computing, then reliability, then AI-related topics, data-centric AI, trustworthy AI, AI at the edge. And some of these have been repeated from the last years. Not all, but some have. Then pandemics and healthcare related. Then some of the industry verticals like space travel, digital twins, and finally productivity tools. So I will go through some of these. I'm not going to read literally all the words. I'll try to paraphrase what is there. Some of them, as I mentioned, I'm more familiar with. I happen to be more familiar with this one. I think it's extremely important. And you will have seen both this year and last year, even though due to pandemics, you would think that remote medicine should be top. We all voted for this one as a top because I believe, at least, that we all felt that AI, especially data-centric AI, is really critical for all other technologies because it influences other technologies and it helps narrow down solutions. So basically, the problem here is that everyone's doing deep machine learning, deep learning, and the models, AI models, are really growing at aggressive rate, much more than perhaps they should. It's really hard to train the data. There's a lot of bias introduced. Um, these deep learning systems are inherently data hungry systems, and the quality of data, establishing data quality, is really challenging. So if you try to use this data, and especially these AI models, where I under AI say broadly deep learning, machine learning, and other techniques for autonomous systems, it really comes with a safety risk, and we'll mention safety later. So manually curating data, which happens to be primarily approach, although there are other approaches more automated, is really becoming consuming and costly. So there's a lot of opportunities for cleansing data, improving in automated fashion, validating machine learning data. There's self-learning metadata platforms. Um, Data-centric AI approaches to specific verticals could be improved, such as to manufacturing, health and life science, or financial services by focusing only on these. Generating synthetic data free of bias and privacy concerns could be helpful. Improve methods of data acquisition. In terms of impact, by having better data, it relieves the infrastructure pressure, and in many ways, it democratizes AI. It eases the deployment of this data-centric AI by reducing burden on developers. It improves performance and accuracy, and many other things. So enablers for this are the emergence of open metadata platforms, such as this DVC, which is data version control, and data-centric AI movement. So there's a lot of open source movement. There's cloud scale compute and storage solutions, etc. Inhibitors, on the other hand, are proprietary platforms. So many companies come up with very proprietary solutions, and they don't really help. It's hard to identify or unbias them because they're usually behind the walls. So that drives the lack of trust. The next one is remote medicine, which isn't hard to imagine. I mean, all of us who visited doctors as of lately have realized that they offer now something that wasn't even imaginable in the past, and that is, you rather than going to the doctor, they just hop on whatever, WebEx, Zoom, whatever works for them, and then you conduct. I just visited a doctor for sleep apnea, and he said, well, we met now, we know each other. Next time, it's your choice. You can come to the office, which are now open, or we can do it remotely. So there's a lot of opportunities here, especially, for example, for robotic surgery, which is becoming increasingly important, especially for the areas where there aren't too many doctors. So if you want to deliver something, you can in the nearby hospitals, but you can conduct surgery from a larger distance. Obviously, the issue is now with the networking and how can you execute on these, including the protocols and many other things. Enablers are definitely fast communication, new machine learning algorithms, new types of accelerators which can help, and inhibitors are cost, need for explainable machine algorithms. It's really critical when lawyers intervene if something went wrong, explaining what went wrong, then regulatory and insurance reimbursement models, etc. Regulatory compliance always trails technology. Health safety and wearable biomedical technologies, really important. Predicting, when to close things, how to conduct safety, really important. Opportunities are in data security, trust issues, connectivity improvements, recurring costs from batteries, because usually you are using these wearable biomedical technologies with some batteries, so it's hard to charge these chips, sensors, deploy them. Impact is in earlier detection of health issues, better global analytics. Sustainable solutions are in integration of wireless charging, energy harvesting, more integrated analytics close to the edge devices, because it's really hard to collect all information that is deployed in the field. Enablers are electronics miniaturization, better efficiencies, microfluids, etc. Inhibitors are, again, regulatory requirements. They happen to be almost everywhere. Regulatory in general, you will have seen in all my talks, becomes, especially at this high rate of technology development, where it takes a really long time. It's not that it's anyone's fault. It just takes a lot of time to get regulatory compliance right. Then cybersecurity of critical infrastructure and medical biological supply chains. Securing digital vulnerabilities in our critical infrastructure is really important. You know that now that everything depends on a critical infrastructure, taking off power can be really detrimental. And the same is true for any attacks. So really important aspect. Opportunities are in more tamper-proof, independent monitoring. By the way, it's few of us, so please feel free to slow me down. We can focus on certain things, or otherwise I'll go quickly through these to spend a little bit more time on comparison. Enablers are new focus on supply chain modeling and new initiatives. Then open source software security initiatives. Inhibitors are increased coupling and interdependence on almost all components in distributed systems. As you know, the true definition of distributed systems, I'm not sure who said that. Was it Butler Lampson or someone else who said that distributed system is the system where something fails when component failed that you are not even aware of. There's a lot of dependencies, especially in these critical infrastructures. I'll spend a little bit more time here because I proposed that one, and I'm familiar and I can provide you better explanation. But in the past, high-performance computing systems were really narrowed in running on supercomputers, especially the very high-end supercomputers. And nowadays, these are exascale, 3 exascale supercomputers that will be delivered to our DOE US national labs. But they are coming out of these shells because of the adoption of AI and also convergence with data analytics. Everybody realizes that these really tightly closed loops that they were running in the past are now also using AI techniques. So it's not anymore tightly coupled loops run through either MPI or PGAS models, global address spaces. Now that they also have a variety of accelerators and AI models which could potentially converge an unpredictable time, the whole approach to traditional HPC is changing. I have also observed that there was very little virtualization. As of lately, they started introducing in a very limited way, but with the introduction of accelerators, which are executing really short kernels, duration in time, the matching abstraction of the serverless or function as a service opens up some opportunities there. So the impact is in solving problems that humanity is facing beyond the scale that was possible in the past, especially if you can connect a number of supercomputers in a country. They're still geographically or government tied, so it's unlikely that you will ever see, unless there's some earth-threatening disaster, that you will see connections of Chinese and US computers, even Europeans or Russians, as we speak now about the war. But within United States, you could imagine, and they already do, but it's at a limited scale, borrowing some of the cycles across supercomputers. But now that there's this convergence and a lot of HPC is starting to be delivered as a service in the cloud, not everything, because these tightly coupled loops are still only possible on supercomputers. But this opens up new ways, more scalable than in the past. Enablers are that there are huge market opportunities you can see to calculate the supply chains, how the virus spreads. All of this really requires a lot of computational power, and that opens up these market opportunities. And also AI and HPDA have much higher growth than HPC. So there's additional opportunity there. There's increased need for addressing pandemics, but also climate change. As you know, there's global warming, which requires a lot of simulation. There's increased use of data lakes for storage, cybersecurity needs, nuclear weapons, and many other things. Inhibitors are, again, proprietary designs by some of the vendors who are not opening up and thereby limiting everything that I said earlier about AI. There's complexity in handling heterogeneity. These vast amounts, I think they're talking about 100 startups working on hardware accelerators. That opens up new opportunities, but also increases complexity in handling them, because while you are avoiding some of the limitations of Moore's law, but highly specializing hardware, you are at the same time introducing new programming paradigms with very interesting programming models, but diverse. So that's really complex for the HPC scientists. AI at the edge has repeated from the last year. I think last year it was the top one. People still believe that it's important, especially in the cases where you need to do the analysis because of the large amounts of data. There are usually heavy edges and there are light edges, but light edges could be extremely scalable, causing the problems in transferring that data to data center. So you really need to calculate it at the edge. So with this, I will really speed up the remaining ones. I gave you some feeling what this is about. You can read it, you can ask me, I can direct you to the experts. So there's safety, reliability, there's digital twins in manufacturing, trustworthy AI, which is tied to explainable AI, disinformation detection and correction, which is again repeated from the last year, but you could really believe that this is important, especially with the war, where you can't believe most of the sources of information that are coming from there. Commoditization of space technology was ranked relatively low, but you know that it's being practiced, at least prior to war, it was happening. Low code, no code is one that I proposed. I still won't go too much, but it's really important for the citizen programmers, those who don't know much. It includes some of us, because we're not experts in all programming languages. So the more we can reduce the boundary to learning, the better. The non-fungible tokens, which are becoming extremely interesting, they're out there tied to digital currency, extremely controversial, which is also related to next generation remote presence or Metaverse. There was a spotlight, industry spotlight by a gentleman, extremely quality talk from Mike Schwind from Meta or past Facebook. I advise you to listen to that. And then there's confidential computing. So I'd like to spend a little bit more time in comparing those. So you can see that on the y-axis, there's prediction likelihood, how likely this prediction will happen. And then on the x-axis, we put desirability. You can see that this team of 18 people ranked non-fungible tokens as the least desirable. They don't believe that they are important or desirable for the humankind. And they also, I'm not sure, it's not that high in terms of prediction. On the other extreme is confidential computing, which is very close to the highly desirable. Confidential computing is important for privacy, but also least likely to happen because of the complexity and many other reasons. Let's go to the top in terms of both prediction and likelihood. It's remote medicine. It's already happening, and it's increasingly more so happening. It is really desirable at the times of COVID, and it's really highly likely to happen. The only one that is more highly likely to happen is Datacentric AI. That was the top one. A little bit less desirable, but pretty high there too. And then there are all others. You can see health safety, wearable, biomedical technology, pretty high there. Convergence of HPC AI and HPDA, both very likely and highly desirable. Probably the most desirable one is safety for autonomous systems. And you can imagine why it is so. We want to eliminate some of the jobs to make even more safer driving by some vehicles that are deployed. But also those drivers could be even assisted for higher safety. And then there's everything else, digital twins, 3D print in healthcare, really, really desirable, although a little bit less likely. Low code, no code, somewhere in between. Metaverse, again, somewhere in between, not that highly likely and not that highly desirable. I also created this picture, which is a different view of this, but it gives you a little bit more view on the standard deviation, which really expresses our confidence. You can see that we weren't as quite confident in the desirability of data-centric AI, and probably not in desirability and likelihood of metaverse. And the last one is non-fungible tokens. There are people who ranked it really, really low here, some who ranked it as high as B. Now, you could legitimately ask me, Dan, okay, so you made these predictions with your team, what makes you sure that any of this will ever happen? And how do we know in a year that your predictions were any good whatsoever? So what we've done over the years, and we started slowly and improved it gradually, we've done some sort of self-scorecard. Now, you can say, well, you are making predictions, then you're self-scoring, but that's the best we could. We could potentially take some other approaches, but this is what we've done. So I compared last year's predictions in terms of success in prediction and our confidence. We also compare them in terms of maturity and in terms of impact. So the size of the bubble describes impact. The larger the bubble, the higher impact, and the colors represent maturity. There's some correlation which in a way has affected us. We're aware of that, but we're trying to improve. So you can see that from last year's remote workforce technologies were by far most desirable and most likely to succeed. And that's probably true. The fact that we're conducting this presentation is there. And then the next one is HPC as a service. And then there are others which might be like in-memory computing, which was surprising to me, that was impactful more than others, but also less mature. They're just emerging. And then there are some incubating, and then there are some which are even at the prototype level. So you can say, for example, low latency virtual musical performance, which is a very interesting one, which helps choir people to conduct their rehearsals or even the performances remotely. And there are products that have been developed, and a colleague of mine actually developed a prototype herself. There's synthetic data for bias-free machine learning training, then election security, which was really, no one really believed, and it turned out to be true that it's neither we were confident, but also success in prediction, it didn't succeed. So with that, I'd like to summarize this part of the talk, and I have a little bit of ads on here, and then I'll switch to the next talk. And then, as I said, that at the end at 8 p.m. your time, we can engage in the questions. So in terms of outlook, technologies will continue to be critical in addressing and preventing pandemics. So it's interesting and important for us to know to predict them. Predictions that we made, these 16 predictions in these 7 areas, we measure predictions in terms of likelihood and desirability. Datacentric AI is most likely, and remote medicine is the most desirable. Most technologies show correlation. They are similarly likely and desirable. However, there are some outliers, which I pointed out. And probably it's important to focus on what we can learn rather than troubleshoot this correlation. In terms of future work, we're exploring how to eliminate possible bias. We try that every year. We are working to estimate impact through total addressable market. We approach some market analysts, and then like every year at the end, we'll do this scorecard. I was going to show you a couple of other things. You can reach me here on social media, by email, etc. We are also related to this whole business of technology predictions. Ian Foster, Rosa Badia, and I are hosting a special issue of January-February 2023 with submission deadline of 8th of July on future of HPC. So that's one opportunity for you. We also have quarterly column in IEEE Computer. The first one appeared in October. I recommend you read it. It's extremely interesting. I'm hosting it, and I change every time who I host. I change Amin Vardat, who is the, I think, VP of infrastructure at Google. He made a lot of interesting observations. So, for example, that the new capabilities will afford a shift from planetary scale interactive services to real-time generation of proactive insights. You know, today they have planetary scale interactive services, but these proactive insights don't exist. They are moving in that direction. He also thinks that without hardware acceleration through accelerators like TPUs and GPUs, many things won't be possible, and they keep on advancing. He's thinking about data compiler, which will be enabling deployment of data, because data is everywhere. Data is needed for everything. So if data compiler is developed, it's not anymore compilation like imperative computation that you compile to, but you take all the data that lives everywhere and then you try to move it around to preload it for the services that may need it. Finally, he thinks that software will drive success of next wave of infrastructure evolution, which I completely agree with. I think it's available for free from either Explore. I'm also holding these corporate liaison program webinars. I listed some of those. We already held another one. I didn't update this. We had like deep learning hardware by Bill Daly. We had like close to 400 registrants for there. It's all recorded, so you can go and watch it. I recommend you pay attention to that. The next one is on next Tuesday, so 6 nights from now. David Tenenhaus will be talking pretty interesting, thinking about what will be required for computation communication in 50 years. He'll start by looking in what happened in the past 50 years and what kind of things can we, obviously he can't predict what will happen in 50 years, but he can at least speculate about this. You can register there if you care. I'm also recording podcasts, so these are not live. Incidentally, tomorrow I will record podcasts on technology predictions where Tom Coughlin will interview me for a podcast about 15 minutes, 20 minutes on technology predictions. I also wanted to point out to you that there's Future Directions Committee that posted a number of technologies. You can see some that graduated, some that are being developed. And I wanted to point out that they are seeking project funding requests. So it's called for proposal. If you have any idea and you need some money from them that will enable you to execute, you can reach out there. This is what you need for this. I think I'll send these slides to Alan so you can take a look at that. Do you have any questions that you may want to ask while I'm waiting for this thing to come back to life?
Yeah, I have a question.
Okay, go ahead.
I was wondering, have you looked at the money side of this, like where the investment's going?
Well,
Because that's likely to drive the technology and be a real indicator of desirability.
yeah, we have, and that's what I was telling you about total available market. We made assumptions, but we all went to different market analysts, and that was also this picture here. If you remember, this picture here, the size of these bubbles was impact. It was meant to be money. But I think I have somewhere we estimated on another incarnation of slides, I don't have it here, but we did look at the total available market of these 16 technologies. It just wasn't credible enough, so we decided not to showcase. Okay, I got about 20 more. Sorry?
Oh, I said, did you have any venture capitalists on your panel?
No, we don't. We do engage with them. We do have a couple of industry advisory boards. We have one in Computer Society. We have one at IEEE level. They report in the Industry Engagement Committee, and we have one in Future Directions Committee. And the Computer Society Industry Advisory Board met with venture capitalists. I think one of the past Google, but that was quite some time ago. But I think that's a great idea to reach out to VCs and seek their feedback. We're trying to use these industry advisory boards as a replacement for VCs because they don't always like to provide their feedback for free. But if you want to link us to someone, that will be great.
Okay, yeah. The problem with panels is sometimes you just get a statistics of opinions on what's new and cool.
But that's true no matter what. If you go to market analysts, that's also statistics of what they get from companies. Then they assemble it, they come. It's always the panel. The only question is how broad, deep, how what's the error margin there. So it's always panel. Some are large panels though. Okay, let me quickly go through this, then we can come back to any questions you may have. This is something, and I'll show you later, that we've done over the course of whole year. So we spent almost a year from, I think, December 2020 through September or October 2021. And ever since we were developing that report. The previous predictions were a result of about 1 month of work. This is result of more than a year. I will show you executive summary for the sake of the time. And then I'll go into a little bit more detail about it. So here's the hypothesis in a summary. World is changing, technology is evolving, and stakeholders can help in the process. World is changing in terms of economical, social, technological, and ecological factors. Technology is evolving. We classify them in automation, security, apps, UI, and infrastructure. And then stakeholders, they influence both factors and technologies. So it's kind of a closed loop. Stakeholders are from industry, from academia, government, and professional organizations. We, as IEEE, are part of professional organizations. So these stakeholders can make these recommendations, and they can help both technologies and factors. So how is world changing? Again, this is a really highest level summary of, you'll see that this slide set has about 230 slides. A lot of them result of the meetings of these individual 10 panels, and I'll show you where we've done them. So in terms of economical factors, and this is all from the perspective of the future of workforce. So we are moving from regional workforce market to global workforce market, meaning companies can now easily go into Brazil and hire very capable Linux developers as opposed to hiring them here in Silicon Valley. It happened in the past as well, but now it's much more amplified. It's obvious to everyone that office workforce is going towards hybrid workforce. the mindset of benefits and corporate are now moving to purpose and ecosystem. And I'll explain later what it really means. In terms of social, white and blue collar is changed to new collar people. Diversity is more comprehensive in terms of diversity, equity, and inclusion. Work as means of living is converting into work as a means of fulfillment. For a lot of people, not for all regions of the world, but quite a bit and increasingly more so. In terms of ecology, it's more from reactive to COVID, to climate change, etc., to preventive. From protecting the planet, we go to return to the planet. From signing the treaties, we go to act collaboratively. That's modular recent war, which I don't really want to discuss, but there are issues. In terms of technology, we are moving from automated to autonomous, from social networks, engaging humans, to sensor networks, including machines, and then from stovepipes in technology to interdisciplinary co-design. And this is not completed. I'm still adding a little bit to this. So this is the current state. Technology is evolving from telepresence and AR, VR to human-machine interfaces, digital twins, from AI-assisted to explainable mission-critical AI ops, from robots in fenced environment to real-time responsive collaboration. That's in terms of automation. In terms of security, from privacy-preserving to privacy-driven, really important difference. From AI-assisted cyber analysts to AI machine learning replacing analysts. And then you can read about these. I don't want to read that anymore. Apps, UI, how they're changing, and infrastructure as well. So I'd like to just point out this is my interpretation of maturity and technology readiness. We're still going to review this. This is the current snapshot. But not all technologies that we discuss, which I didn't even present to you, some of them will continue forever. Some will have the end of their life by, delivering. But this is probably the most important slide of this future workforce. Some of the recommendations, and I'd like to start from academia, move to government, industry, and then professional organizations. So for academia, retraining for new technologies is really important. We heard that everywhere, in Brazil, but the same in Canada, certainly in Africa, India, China, elsewhere, but even in the United States. Interdisciplinary, global, we need demand for skill that is changing as a result of technology progress and globalization. So we need interdisciplinary training and global, not just stovepipe. Learning never ends. It's important to train individuals to learn how to learn. In terms of government, recommendations were to establish sustainable workforce in a well-balanced labor system. It's a really, really tricky thing to do that. You can't do just some sort of regulatory compliance or regulations. It has to be comprehensive workforce, this well-balanced labor systems, which ties in industry, academia, government, which introduces governance rules and takes care about taxation and many other things. They need to look holistically at technology and society and then balance properly labor markets, which is kind of derivation from the first one. In terms of industry, some of the recommendation is that it is all about people. And I, both as a technologist, technology leader, and manager, am fully aware of that. There's that saying, love them or lose them. If you don't love your people who work for you, you will lose them. You can lose them even then, but less likely. Hire people who can adapt, really important. And then best people bring best people. That's the best way how to hire. Early career employees and new technologies. Technology is a attractor for hiring, especially for early career employees. It's true for everyone, but the early career, they're especially attracted. Office and home have each advantages and drawbacks for different career stages. Young employees, they likely, not young, early career, I apologize. I was accused somewhere that I'm age biased. Early career employees, they are attracted to office because they don't know. I mean, I've been long enough. I know most of my colleagues, and I don't really need to meet them in the office. I talk very effectively with my manager over the Zoom every day or Meet. And then for professional organization, that's IEEE. So this is really interesting, I think. What can we do as volunteers? We need to help redefine concepts, define hybrid career for all of us. We need to assist both individuals and corporations. We need to leverage our power of convening. This is what Alan has done here by convening all of us here. We need to educate legislators, make technology predictions and roadmaps. That's what I've been doing here. So I'm kind of, preaching to the choir, or as I think David Cutler from Microsoft said, eat your own dog food. If you want to develop operating system, you need to run your things on it. And then derive principle and best practices for trust, transparency, accountability, and policy. So this is executive summary of what we've done. So let me show you a little bit more. Have about 8 more minutes. So why this discussion? I already told you a little bit about the reasons in the previous, because of the stress that pandemic has made. Predicting future workforce will help address pandemic, rebalance the workforce, remote work versus in-person, and many more. So our hypothesis when we started was this. Please read it. It's really important. So, I'll skip the process, but this is what we've done. So in December at Switch, we ran the first one. No, it wasn't at Switch. It was with individuals. So the process, the way it works is we find someone in the region who recruits appropriate people, usually between 1 and 2 dozen people. I'll show you some examples. And then we hold 2-hour panel. We give first hour presentation, which is interactive, and then in second hour, they help us. And I literally type during the meeting their recommendations. Then we went to India, and there's some method to this madness. I purposefully went from relatively underdeveloped to more and more developed, at least from the maturity of the market, if not from the market perspective. So we went to India, then to China, Sub-Saharan Africa, Latin America, Europe, and MENA, Middle East and North Africa here, which I felt were more closely related from the future workforce market than Sub-Saharan. Then we went to Northeast. So that's your region. I wouldn't say that. So rules about maturity of the market is broken here because I really wanted to start with Southeast or Canada, but it didn't work out. So we started with Northeast, went to Midwest, Canada, and ended up with Southeast. And now we are working on this final report. So I'll skip this. I want to show you some early insights. We look from the regional view perspective, and we made some recommendation. These slides were us coming into the region, presenting to them. Then we had corporate view, where we made some recommendations, what corporations can do. And then we made recommendations about individual views and what individuals can do to help themselves. And then I speculated about technology curves in the way that during pandemic, some curves have been flattened, that is lengthened, and for some technologies, they were accelerated. And we mapped some of these technologies here. So you can see these. The other view of the same thing is that while some technologies were affected, others were thriving. What we should really do is build back better, give back to Earth, rather than just going for the money, because if we all bear the consequences of the global warming, it won't help certain regions that they became rich. We'll all be affected. So it's better to return to the Earth. And then this is classification, some of the factors that we went into detail, just like you see technology predictions we've done for these factors. and we've done the same thing for these 15 technologies. We tried to correlate them. This was coming in, and we've done some correlation afterwards. You'll see that. This is very interesting paper in IEEE Computer on risk versus benefit in terms of abuse due to COVID and potential benefit of remote workforce. We made some regional insights. It's surprising that some are very region specific. Like in Asia, they really care of individuals in times of pandemics. In sub-Saharan Africa, they cared about Africa-made devices and bias in AI. In Latin America, there was decrease in internet for mid-class up to mid-class. Mid-class and up were covered, but anything below that, they had problems, so they couldn't conduct education because of the lack of broadband. In Europe, in MENA, they were caring much more about purpose, new colors, ecosystems. In North America, it was all about people. Education is key. Transformation of the workforce, priorities, and loyalties. And then there are some which are global, like workforce mobility, climatic, political, socioeconomical forces, re-education, rural divide, etc. And I'll speed up. I want to show you some survey results. I'll skip generic disclaimers about employment type, who did, gender distribution, work cloud. Didn't reveal much. The factors that were useful here are, sorry, I didn't point them out, but you can see some outliers, like changing balance of power was not as likely, which was surprising, nor desirable. Transparency was extremely unlikely, which was surprising again to me. Then bring your own thing or Internet of Things was considered extremely unlikely and undesirable. I was surprised by that one really, really a lot. Same is true for blockchain. Robotics was deemed both relatively desirable and likely. As you can see, cybersecurity and telecommunications are both desirable and likely. And then everything else is in between. Then there are factors correlation. What surprised me here is that there's very little correlation between technology and economy. And there's really high correlation between, I'll come back later. This is factors. When I come to technology, I'll show you. Here's some more ways of technologies. And then comparison about factors. These are the same as earlier. I was going to show you something else. And yeah, no. What was surprising, and I didn't put it here, but there was very little correlation between technology and societal factors. And sorry, between technologies and economy. That's what I wanted to say. So between economy and technology, very little here, whereas there was much higher between technology and societal. And it occurred to me that we largely interviewed IEEE people. And you know, the tagline of IEEE is advancing technology for the benefit of society. So there's inherent bias there. So we're trying to address that bias, but we'll most likely not be able to do it here. So I'm almost running out of the time. I went over these recommendations and summaries. I was just going to show you at the end how we conducted these. There's some further reading. That report will be released. There's some testimonials. People really liked it. Here's the staff that helped us a lot in various regions. And here's 8 people who conducted this effort. I was going to show you some of the regional reports. For example, from Southeast, these people helped us recruit. Here are the people who attended. And then we had these experiences from region, and then I literally typed during the meeting recommendations, and then I highlighted some insights. So that's it. We're exactly at 8 p.m. and I'd like to stop here and give you opportunity for asking questions.
I think.
Go ahead, Tom.
Oh, okay. Yeah, I think you might have alluded to that when you were looking at Geo Insight, but I could see a hierarchy of need in there somewhere, and that's got to be skewed by the money. Have you looked at that kind of thing? You look at, when I say money, people will invest in it when they see they can profit from it, which might be different than a need.
So can you, I mean, in theory, I agree with you, but there's the law of numbers. So if you look here, you got China, for example, with huge economy nowadays. You have India, which huge market. The largest growing market is in sub-Saharan Africa. So even though you can think that you may have most money here in Northeast US or in Silicon Valley, the power of numbers here can outrule all of that. And
If they're organized, sure, then you'd have that power. But I presume that they are underdeveloped because they don't have those numbers and organization.
but they are growing. If you think what happened in China 20 years ago, it's completely different nowadays. And the similar things are happening in sub-Saharan. I think internet is kind of equalizer here. People can gain knowledge from attending MIT courses from anywhere in the world.
Sure.
So it's slow. It's slow growth, but it's trending towards equalization. I agree with you, but I'm just saying it's not as emphasized as one may think.
I mean, I'm looking at the rate of change because even in the underdeveloped populations, you have those that have greater access.
Yeah, that's true. And then there's skipping technologies, as you know. I've seen, and that's been spoken about for many years, about people programming in India on mobile phones. They have young developers who can code on mobile phones, and these were all Nokia phones where you had to type 3-4 times until you get the desired letter or number. But now that happens in terms of finances, these exchange rates that they do, local currencies in sub-Saharan Africa. So there are drivers that skip the technologies.
Well, that's true. I think it's known that the developed countries have inertia with their infrastructure.
Yeah.
And
Okay. Other questions?
Okay, this is Alan Jones. I've got a question, and you sort of touched on some of this in the latter part. One of the things that we try to do when we're picking meeting topics is say, okay, what is it that our members need to know for the future so that they don't get caught off guard and not know the latest technology when all of a sudden they have to apply it. And you touched on some of it. You mentioned interdisciplinary training and learning to learn. If one of the topics, for example, is cybersecurity, and last year we held a panel session on what every software developer should know about cybersecurity. So we got a bunch of cybersecurity experts together and said, okay, if there's certain cybersecurity things that you keep running into and you just wish you could sit all the developers down and tell them, don't do this kind of a thing or do that kind of a thing. What similar topics do you see on the horizon that you think at some point in the near future, it's going to be what every developer needs to know about artificial intelligence or
exactly.
what have you.
Yeah, it's really and it's not just AI, it's AI and data analytics, because and data analytics was in the past known more as intelligence community or social networking, where they would, analyze individual access in order to earn more money from them. But now more so everybody needs to know and wants to own their own data, and needs to, in any profession, to derive some conclusions. So AI is more of a tool for data analytics. So these two go hand in hand. And the same might be true even for high performance, because there's more and more computation. So these three are for me important. And so that, how do you apply machine learning, deep learning in some high level languages that can result in improved productivity of developers?
Okay. And then a related question on AI. We're planning a talk on HPC, so it sounds like we got the right choice there. But on AI, one of the things that when I was doing some classes on that recently, it seems like a lot of the models, it's not very explainable why the model came to the conclusion that it did, which makes it then hard to determine, okay, was that a biased decision or an unbiased decision, or did somebody intentionally hack your data to throw you off? Is there any work being done there to help make the conclusions that machine learning models come up with more explainable?
Well, there are two parts to it, okay? The first part is data that comes in. You say garbage in, garbage out, because these algorithms, these models, they are created from some data. So if that data that they use for training is not good, then it will draw the wrong conclusions. If you use the pictures of white male, Caucasian, the algorithms will be biased in that direction. That's what people in Africa were pointing out, that they didn't have any sufficient algorithms for people from that region, and for women it was largely white people, and so that's why they wanted to produce the phones in Africa. So that's one aspect. The other aspect is computation. When you execute the models and the algorithms, how does it execute? So there's some at labs where some of my colleagues, not me, are working on explainable hardware architecture that can roll back exactly how they came to the conclusion. So if something catastrophic happens, they can roll back algorithm, and which is not trivial with GPU and other more general purpose architectures. But these hardware architectures that they are developing are leading towards explainable. So these are two things. One is on data, the other is on hardware.
I'm wondering if maybe the solution is the combination of the hardware part, and as the industry gets more inclusive, you're more likely to get somebody go, wait a minute, this thing came up with this conclusion, and I don't agree with it. It doesn't fit my view of the world, and then somebody questions it, whereas otherwise they may not have questioned it.
Well, I agree, but hardware is hard to develop. It's not trivial. But the problem is people see that they disagree with the conclusion. But the problem is, how did you come to that conclusion?
Right.
So you cannot roll back the algorithm. You can't even, in many cases, roll back the data that is used in model for training model because it might be gone. You just have these models. So you can't analyze. If you have everything, then it's a different story. Then you can reason about it. Okay, other questions? You can ask questions about anything, not just about these two presentations.
Okay. If nobody else has any questions, we'll go ahead and end it here. We'll let those who joined late know we are recording this meeting, and so in the next couple of days, I'll go ahead and post it, and you'll be able to go to the same meeting link that you used originally to register for the meeting, and that's where I'll update that meeting announcement to include a link to the recording of this presentation.
Okay, thanks again for having me, and thanks for staying along on Wednesday night.
Okay, Dejan, thank you very much for speaking with us.
Okay, bye everyone.
Okay, bye.